Knowing the electron gain enthalpy values for O to O minus is minus 141, which is exothermic. Please note the negative sign. And O to oxide ion are 702 kilojoules per mole, which is grossly endothermic, my dears. Please note. Respectively, how can you account for the formation of large number of oxides having O minus 2 and not having O minus? What kind of question is this? Did you understand the question itself? What they're trying to say is this. Okay, if oxygen forms an ion with single charge, minus 1 charge, this reaction is exothermic, very favorable, it releases energy. So oxygen should actually have a tendency to form minus 1 charged anions. On the other hand, if you compare, we are aware that oxygen actually forms minus 2 charge anions, di-negative anions. But what they're asking is this, that in order to form a minus 2 charge anion, this is very unfavorable, plus 702. That means you have to absorb lots and lots of energy, which is energetically not favorable. If you just look at thermodynamics, it looks that oxygen forming minus 1 is much more profitable and forming minus 2 is much less profitable. Why is it then oxides contain minus 2 oxygen and never, nearly never minus 1 oxygen? Can we explain? This is the question. And what is the answer? We can say that yes, formation of minus 1 may be energetically favorable, exothermic, and minus 2 is endothermic, which is bad. But then I just don't have an ion, I also have a cation, and after cation and anion have reacted, I have an ionic lattice. Minus 1 and minus 2, if you compare, as the negative charge or in general any charge on cation or anion increases, lattice energy increases like anything. If you just compare, fluorine has minus 1 charge, and with sodium, if you have fluoride, the lattice energy is barely 923 kilojoules per mole. If you have oxide, it is 2481 kilojoules per mole, which is very high. Why the sudden jump? Now please note, O minus is something which would be a little bigger than F minus because of less nuclear charge. Charge is minus 1 only. So in case we had Na plus and O minus, lattice energy would have been even less than 923 kilojoules per mole. On the other hand, if oxygen chooses to form minus 2, although minus 1 to minus 2 may sound bad, it may sound endothermic, but there is a silver lining, more than silver lining actually. If oxygen forms minus 2, then minus 2 with cations would have much greater exothermic, much more exothermic lattice energy. And this extra lattice energy, this extra energy which is increased, which is released in formation of lattice, compensates for this extra expense which you might have incurred in forming minus 2 anion of oxygen. One more example, fluoride is just this much, oxide is considerably more. That extra energy is of course released because now oxygen has minus 2 charge instead of minus 1. And this extra lattice energy, my dears, compensates for the extra energy absorbed in formation of oxygen di-anion.